Hi everyone. So let's start the session. First of all, welcome for the today's session. Let me introduce myself. I am Harshita from Verzeo, and the topic for today's webinar is robotics and its applications. Okay, so let me give you an introduction to our mentors. So today we have with us Mr. Rohit Chadha, who is the co-founder of Indian School of Robotics, and Mr. Vijayanand Mishra. I guess is not yet present. So both of them will be sharing their knowledge regarding their expertise with you all. Let's welcome them. Mr. Rohit, the stage is over to you now. You can start.
Thank you so much for such a warm welcome. Uh, Good evening, students. I hope all of you are doing well. And just welcoming you again to this one of the expert sessions on robotics and its application. Just a very brief introduction from my side. I am Rohit, and I am one of the founding members of Indian School of Robotics, and I am also the Chief Education Officer over here. So I basically design the curriculum and take it to the students, and also I am also one of the educators here. That is one of the part-time job I do. I also teach students, so I have all the experience in designing the product as well as teaching students what they need to be taught in robotics. Right. So I hope this will be quite a good interactive session which we are going to have for next 60 minutes or so. And I'll be covering very basic and interesting knowledge about robotics and also how and where robotics can be applied, and also how you can learn, how you can actually benefit from robotics. So let's start. I'll just share my screen. Right. So I hope the screen is visible. So I have already given the introduction. So just little more points about the organization. ISR is based out of Chandigarh, and we are teaching robotics since 2016, and we are associated with NASCOM, Department of Science and Technology. I am Kashipur, which is Indian Institute of Management, and FEED. And over the years, we have catered to a lot of schools, young students, as well as colleges and universities. So, whenever we talk about robotics, we usually feel that it is a very technical skill or a very technical domain. But I take it otherwise. It's and technical knowledge, but it is more of a life skill. So when I say life skill, it helps you develop you as a person. It develops personality in you. So that is how I take robotic discussion, that how it actually helps you develop your personality. So take it in that way. So that will make it more interesting. And even though you don't have any interest in technicalities of building robots or coding, you will still love it because of the life skill component it involves. So these days, especially in last one and a half years, we hear a lot of terms which I'm showing you right here, like robotics, coding. Then we have machine learning, we have AI, then programming, STEM, then a lot of iOS and Android apps, tinkering. So these are basically 21st century lingos. So why I'm calling these lingos? Because these are some keywords or these are certain skills which we need to have for a better career or better progress we want to have in life, because this is what the future is. Future has the last revolution was industrial 3.0, whereas the current revolution or the upcoming revolution is industry 4.0, and the 4.0 involves robotics. So these are some of the keywords which is to have a better career prospect, because in future all the technology or all the work will revolve around all these things, whether it is AI, ML, robotics, and coding. Right? Just feel free to ask questions to me anytime. So before moving forward, let's spend some time on what is tinkering. Any idea about tinkering? Anyone? What do you mean by the word tinkering, and why we need to have this tinkering when we're studying robotics? Anyone? All right, no issues. So we all know that how Newton discovered the concept of gravity. It was he observed the apple falling down from the tree. But again, the tinkering has more moved from Newton's Apple to Steve Jobs' Apple. We have so advanced Apple mobile phones, laptops, and iMac. So he just solved the problem. He thought about the problem and he came up with a solution.
Sir, your voice is breaking.
Heard about printing the. There's always a skill. All right, just a second. Am I audible?
Yes, sir.
Yes, all. So we always have these scarcity of organs, for transplant and others. So again, there is an idea, or there is a thought, or there is a approach to solving that problem, which is why can't we print 3D organs? Again, coming to a concept which is known as digestible sensors. Now, what are these? See, whenever we take medicine, uh, the chemicals in our medicine or salts present in our medicine, they go they spread across our entire body apart from the area where they are really required. For example, if I am having a headache, I'll take combiflame. So combiflame will definitely solve my headache, but the chemicals will also go in other parts of my body. So why can't we have certain medicines which can send the salt and the chemicals only to the part which is having pain. In my case, that is my head. So again, this is the kind of approach we need to solve our day-to-day or the day-to-day problems. That is what is known as tinkering. So we need to sit down, we need to jot down the ideas, and it may not be any traditional approach. We need to think of crazy ideas. Again, we have smartphones, we are using smartphones, but what about VR or the virtual reality? So where we can actually feel these whatever, we can feel the objects which we are seeing in the smartphones. So in a nutshell, tinkering is about trying new things and looking for solutions to existing problems. So why I'm telling you about tinkering? Because tinkering is one of the first steps when we go towards robotics. Robotics is all about solving problems or making tasks for human easy, or making some machines or devices where which can work in those places where humans can't go, such as some radioactive site or something like that. So again, the solution will require out of box thinking and for trying new things. So that is why tinkering is very initial step. So we need to get very mastery in thinking, then we can go on and solve the problems and make the robots and further go on making various applications. So it has very tremendous benefits. It helps us to develop certain key skills we call. These are problem solving, creativity, logical thinking, and also
Sorry to
collaboration.
disturb you, sir. Everyone
Yeah.
in the chat is saying your screen is not visible actually. Yeah, now it's visible.
Okay. Okay. So I think you might have missed this slide, which is about going from smartphones to VR. So again, I like to summarize tinkering process. It is approaching a problem and solving it using your creativity and making something out of box. Be really crazy about finding the solution, and it is the first step towards robotics, or even when I say about coding or programming. So whenever I say about robots, we make a certain image in our mind that this is how a robot is. So have any one of you came across any robots in your daily life? Have you seen any robots? Anyone can answer. Yes, tell me. I think it is in chat. Someone has written yes. Give me the example. Like, what have you seen as a robot in your daily life? Right. Automatic washing machine. Great. Absolutely right. Really a wonderful answer. But I get very few answers like this whenever yes, Alexa, great. Alexa is also drones. Yes, we can qualify drones as the bots. So whenever I interact with students, I get very few answers. Usually students say, they have seen in movies and some sci-fi science movies. So they describe robots as something which is similar to human. Yes, people are giving answer chatbots. Yes. So they describe robots as something which is similar to humans. It will be tall, 5.5 feet, 6 feet tall. Yes, someone has written Terminator type. Abhishek has written. Great. So that is how they describe. It will be tall, it will be like human, it will be having hands, legs, and they'll be doing work which humans can do. Yes, Sophia. Sophia is one of the bot which we have, right? So, so this is how everyone describes the robot. Similar to human, but in actual life, the bot could be as tiny as you can say, 1 square centimeter in size, which is like the size of an ant, and they can be as big as some industrial robots, like as big as JCB machines, which are doing a lot of complex tasks. So robots may not or may be like humans, but they may not be like humans. So one of the example which someone gave was of automatic washing machine. So it is actually a robot. How? Because it senses the latest washing machines we have. These are intelligent machines, and they senses how much water is needed to wash the clothes, depending on the dirtiness of the clothes. So it will sense how much amount of water is needed, how much amount of detergent is needed, and it will mix it and wash the clothes intelligently. So this is what robots is all about. Similarly, we see a lot of devices in our home itself, which we can classify as robots. One more example I'll give. When we go to malls, usually there we have these automatic doors which opens as soon as we go closer to them. So how does it do? It senses the presence of human or object and it opens. Then there are other examples, very common example which we have in our cars, latest cars we have. So when we reverse the car, there's a beep sound if there is an obstacle behind the car. So again, it is sensing the obstacle and alerting the driver. So it is making the task of driver easy. It is assisting in driving the car. So similarly, we have got a lot of examples. So the bot is not necessarily a kind of a machine which will look like human. So that was the point which I wanted to make, just to give more the clarity. Yes, Veena is saying automated lights in buildings. Yes, exactly. So what we call them uh, are as the PIR lights, PIR lights. So these lights gets turned on when we go closer to them, or there are some lights which will get turned on as soon as there is a sunset. So we don't need any physical effort to turn on and off the light. So these are basic examples of robotics, and these are actually the applications where the robotic skills can be applied. So coming to the process of robotics, it is divided into three parts. One is we need to design the robots, how our design should look like based on the task. So if I talk about automatic lights in building or automatic street light, I need to design that light. It should have a pole, and how many LEDs it should have, what should be its wattage, and what should be the height, and what should be the angle at which the LED should be installed. And then I have to go for making of the robot. That is the second step we have. I have to assemble all the components and make that LED or the automatic street light. And lastly, I have to program it. I have to program it so that it can turn on and off automatically. Or in case of washing machine, it can actually sense how much amount of water or detergent is needed. So robotics involves building of the bot and programming. So this is how the robot, which usually people think looks like. And if I go to the actual definition, it is a uh, electrical and a mechanical machine which has got certain capability of doing a task or making any work easy, and it is guided by a controller. But now, why it needs to be guided? Just like humans, we have brains. We sense signals from our environment, and then we process it, and then we do action. Similarly, machines needs to have a controller, or another name for controller could be the artificial brain of the robot. And through this brain, only the robot will be able to perform the actions. And this robot may or may not be autonomous. So what I mean by autonomous is it may be completely working independently, or human may be required to assist in the task. And as I told you, it may or may not be in human form. It can be in human form, or it may be specific to a task, like washing machine or street light or a automatic door. All these are specific to that task. Now, one thing which I wanted to touch upon over here is when I talk about brain of the robot or controller of the robot. So this is actually the part of the robot which controls the entire function, how the machine is going to perform the actions, right? So again, how will the robot know which action it has to perform, uh, or what kind of signal it has to sense so that it can perform the actions? So how it is going to be done, though we have given the controller or the brain to the machine, but how this controller will work? So this controller will work through program or coding. Like we are communicating with each other in English, but English is not the language which machines or robots will understand. So we need a different language which machine can understand, and communicating with the machine or giving instructions to machine in that language which they can understand is known as programming, or also known as coding. Any questions till now? Any questions? All right. So again, I'll just touch upon the examples, though we have already discussed. So we have a automatic machine, then we have a fire alarm. It has a smoke sensor. It senses the smoke and alerts the fire department, and also sprinkles the water in that area. I have already talked about the uh, reverse parking sensor in the cars. Then this picture is about the automatic door. This is about the automatic light, which someone, I think Veena, has mentioned. And lastly, we have this machines in our offices, which are basically attendance machines. They either senses the biometrics and recognizes the person, or using fingerprint. So all these are machines around us which are actually the application of robotics. So how we can design a robot? Suppose you got a task, whether it is of, you got a task, you have some problem in mind which you think can be automated and can be done by machine. So these are basically 4 or 5 steps which involves in designing the robot. So firstly, we go down and zero down on identifying a problem. Then we do the tinkering, which is thinking out of box and generating multiple ideas. So one idea is not perfect. We need a lot of ideas. These ideas could be in design of the robot, maybe in programming, or maybe in task, how the task is to be done. And then we need to go for testing of these ideas. After testing, we'll get some result. We need to zero down on one of the idea which is giving the best result, and then we need to add technology to this idea and give it a proper shape. So adding technology means we need to uh, you know uh, maybe that device needs to be controlled using Bluetooth, or maybe that device needs to be connected over Wi-Fi, or it may be controlled using a remote control. So that is what I mean by adding technology to the idea. And then we need to design the prototype. That's how we go for process of making and designing the robots. What else we can do from robotics? We can build and fly drones. I think someone shared about drones. So this is what we can do. Again, drones is a kind of electromechanical machine which has got intelligence. How it has got intelligence? Because we can feed coordinates where we want drone to go. So it can have a GPS device. So if we feed the coordinates, it will go there automatically and can perform the action, maybe clicking pictures or dropping some material. We can have a fingerprint door lock instead of a usual door lock with a key. We can have a fingerprint door lock. Again, this is kind of a device which we can make using robotics. We can have an all direction robot. Again, this could be useful in this. The application could be in warehouse where we want some heavy loads to be shifted from one place to another. Or we can, even a 3D printer is a kind of a robotic machine. Again, it is an electromechanical machine. It can work automatically, and once we feed in the instructions. So these are 3D printers. Anyone has worked on 3D printers or flied a drone? Again, we can have one machine for sorting, a machine specifically made for one application. Like here you can see, this is a machine which is used for sorting colors. So if you have a lot of objects, especially in warehouse or in some factory where you want objects to be segregated as per color, So we can have a machine for that. So it will segregate all the objects once they pass to the machine based on the color. Again, we can create mobile apps and use these apps for automating our home. So we can switch on and off lights and other electrical appliances using a mobile phone. So again, this is a kind of application of robotics. We can create games, though it is not actually robotics, it is more about coding. So this is one of the thing which we can do. Now, one of the integral part of robotics is giving intelligence to the machine so that they can work automatically or semi-autonomous or in semi-autonomous mode, or these robots have got brain inside them, and these brain need to perform certain actions. So how they are going to perform actions? They are going to perform actions using programming or coding. Any idea about programming language? Any one of you? You must have learned in your colleges coding language. If you can name anyone, right? C, C++, Java,
Python.
right? Python. So, what is the difference between coding and programming? Are they both same? All right. Veena, can you explain what is the difference? Like,
Yeah, sir. Like coding is like you literally don't get to know, only you know the problem statement. You must be able to
okay,
create everything. Programming is like you will get all the sufficient need. You just need to program. That's it.
okay, great. Anyone else? Are both same coding programming, or there's some difference? All right, let me put it in another way. So we need to code the robot or program the robot? Or
Program the robot.
all right, great. So let me go to one example. So I'm sure that you must be familiar with this very simple program, which is for finding sum of two numbers. Yes, Satvik is saying coding is writing, program is execute everything. Exactly. So in this program, the individual lines are known as code. This is how we try to simplify understanding. So line number 9, where I've written number 1 is equal to 15, this is a code. So I'm translating my requirement into a language which machine can understand. So that is known as coding. And the entire codes, like line number 1 to 16, which will execute or perform some action, as Satvik has said, they will execute something. That is known as programming. So that is a very small technical difference which we must be aware of, which is difference between programming and coding. So I think everyone know that there's a difference between programming and coding. So these are the many coding languages we use in our for coding of the robots or giving them instructions. These are Scratch, C, C++. Then we have embedded C, Python. Then higher languages we have machine learning and AI. Anyone exposed to embedded C, Arduino, something like this? Has anyone worked on embedded C and Arduino? Okay, right. Couple of answers. Yes.
It is similar like Raspberry Pi, na?
Raspberry Pi is more advanced. So Raspberry Pi is it's like a mini computer, which has got its own RAM and own memory. But Arduino is very simpler. It's like the first step towards robotics or automation, right? So I think many of you are quite aware of embedded systems and Arduino, right? So let's move forward. So so one of the critical things which when we interact with the students, and I especially interact with students, are that they don't know where this code, they are working on the code or the program in their laptops and computers, but they don't know where this code is actually going to sit in the machine, or how it will actually go to the machine. So again, this slide depicts that in a very easy way. So we need to write codes and then make the program, and then we need to download or transfer this program to a machine. When we download or transfer the program to a machine, it will sit in the brain of the machine or the controller of the machine. And thereafter, when we execute the program, we will get certain output. And then we need to analyze these output, whether we are getting it as per our requirement, or we need to change anything. Now this change can be in two parts. One could be that we have made a wrong code and the program is not executing properly, or the design of the robot is faulty. So we need to look at the both aspects and find out the problem. This approach gives us the problem solving aptitude. So when I talked about robotics as a life skill, this is what I meant by this. We need to write codes. Before writing codes, I need to have a solution to the problem. So for developing the solution to the problem, I need to have that logical thinking mind. Again, logical thinking is not a technical skill, it is a life skill. Whether you pursue your career in robotics or not, you go to any field, you need to be logical thinker. So this is what robotics helps you to become. It helps you to become a logical thinker and develop logical thinking aptitude. And during robotics, when you don't get the output as you desire, then again you need to go back and find the problem. This helps you develop the problem solving aptitude. Again, the problem solving aptitude is not a technical skill, it's a life skill. So again, any job you go for, uh, in any of your career options, you will need the problem solving aptitude. And the third thing which helps you in robotics is the creativity. You need to be very creative in finding solutions to your problems. It could be Solutions could be in form of the design of the robot, or maybe code or the program. It could be very efficient program which is able to execute very quickly. So again, creativity is a life skill. You choose any career option. Creativity is something which you will need. So that's how robotics is technical also, and also helps you gain certain life skills which you will need irrespective of your career options.
Okay, ma'am, go ahead. Yes, ma'am. Okay, so
Right. Now, so how you can learn robotics? Firstly, you need certain parts. These are electrical and mechanical part. So there are a lot of parts available in market in form of education kit and education toys. But there are many open source parts also, like Arduino is there, and you get a lot of sensors in market and LEDs. So you need these parts, and using the concepts of science and maths and basic physics, you need to build a device. Suppose you want to make a pick and place robot, you need to apply the concept of center of gravity, where we center of gravity in the device so that the device is balanced. So you need to apply this concept to build a machine. And once you have the machine, you need to go to the third step, which is programming. Here you will use logical thinking to make the program. And lastly, the fourth step is analyzing the output. This will involve problem solving if you don't get the result as you desire. So these are the four-step process which you can easily follow at your home to learn robotics, get the parts, and build, program, and test the out. Any questions? So just sharing two examples. Student I gave him these almost 50% out of made a self-driving car. So how it is self-driving? It has got certain sensors like IR sensor to know its way. Then again, I gave one of parts, many parts to one of the students, and they made the color sorter machine, which I have already explained. So this is how we can make. So again, it is not fixed or fixed like from these parts you can make only this thing. So this is the creativity of that student, that he can make a self-driving car. You can make anything from this, based on your creativity or the task you have in hand. So there is nothing fixed in robotics. It depends on your creativity and your imagination, what kind of model or what kind of device you want to make. Coming to the controller or the brain of the robot. So there are many types of brains available. Like someone mentioned about Raspberry Pi. At that time, I told you it is very advanced version. And someone has written in chat, I think it is ESP32 has its own RAM. So again, there are a lot of different kind of brains available in market, which you can use for making the robot. Like the first one is the Arduino. Then we have got Nano. Now, how will you know which kind of brain you have to use? So if I want to make a device which is very small, so I'll go for Arduino Nano. Size is small. If I want to go for something where I need to process a lot of data and attach a lot of sensors, I may go for Raspberry Pi. This is the Raspberry Pi. If I'm making a drone, I'll go for Ardu Pilot. And these are other brains like Lego EV3 and Vido. So there are a lot of brain. Yes, Abhishek, Uno is for basic. You can start with Uno. So one written why developers prefer C instead of Python in embedded. I really don't know the answer, but I'll tell you what we do. So why I use embedded C for teaching is why I use embedded C for teaching is because it is very easy language, and most of the students are quite familiar with C and C++. So it is very quickly they can learn robotics using embedded C. That is the reason I use C in the initial phase, and Python I use for AI and machine learning courses. Or when I want to teach machine learning, then I go for Python because it is a object-oriented language. It is more the, it can through Python I can do a lot of things which I can't do with C. That is the reason. But it's the choice of the developer which they want to use. One more question from Hitul: how will we connect the Raspberry Pi and such device? Which Hitul, can you elaborate on your question? So Hitul is asking how can we connect Raspberry Pi and such device to code? So Raspberry
Sir,
Pi
like
can be
I mean like how to connect with any from mobile or PC like that to do some operations. I mean,
so
how to.
Raspberry Pi can be connected to PC using your HDMI cable.
Okay. Any like a Bluetooth or Wi-Fi is available?
हाँ, you can connect via Bluetooth. उसके लिए you need to buy HC05, which is a Bluetooth device. You need to have that. I don't know whether the latest Raspberry Pi model has got inbuilt Bluetooth. If your Raspberry Pi doesn't have inbuilt Bluetooth, then you can buy a Bluetooth device separately and connect using that.
Okay, thank you, sir.
Yeah. Right. So this was all about robotics. Now, just give a thought. Now, if I have these machines and like a self-driving car, what if you can connect this machine to internet? What will happen? Any idea if I make a self-driving car and I connect to internet? What extra things I can do? Any one of you?
So we can control it from anywhere, any place.
Yes, exactly. So we can control it with anywhere, and I can communicate with that machine from anywhere. So that is known as IoT, or we have heard about this lingo also, Internet of Things. So in a very simple way, that Internet of Things is something when I connect any machine to internet, and I'm able to communicate with that machine from any location. And yes, I also need to be connected to internet. So one of the examples which we see also, and we have seen in movies also, that person is not at home, but he's able to operate devices at his home using mobile phone. So again, these are your appliances at home, like smart TV, CCTV, or AC. All these are connected to internet, and your mobile also has got internet. You have a mobile app which is integrated with your home appliances, and you're able to control. So this is one of the next things which are coming. So we don't need just robotic machines. We need, that is what Industrial Revolution 4.0 is about. We need machines. We need robotic machines which can perform tasks automatically, but also these machines needs to be connected to internet so that they can be controlled from anywhere and can be observed and can be monitored. So coming to the benefits, and so that's how the application of robotics is all about. It varies from simple machines at home to industrial tasks to machines like color sorter, or machines required in nuclear plants, to IoT, to mobile apps. So it involves coding, it involves construction. But what are the benefits you're getting? So as I told you, the benefits are both ways. These are technical, because if you want to really make your career in robotics, then there's a lot of scope, because that is what the Industrial Revolution 4.0 is all about, making machines which can help us humans do the work. Whether you talk about iPad or mobile phones, all these are kind of machines which are actually helping humans to move to next level. So in this COVID and lockdown, we are able to communicate because of a machine, because of the technology, which is the Zoom meeting or Google Meet, or laptops. We have tabs. And apart from these technical skills, even though you don't want to make a career in robotics, you should learn a little bit about it, because it will develop certain life skills in you, like problem solving, creativity. It will help you better understand concepts of science and maths, where you can actually apply the concept. You must be reading in physics and other engineering subjects about a lot of concepts like center of gravity and about variables. So where you can actually use these concepts. And again, one of the greatest benefit which I have personally experienced is that, when I started with robotics in 2016, I was quite little underconfident in whether I can really do the task or not. But now in the last 4 years, I made so many machines. I've been teaching so many students how to make robots. I have that self-confidence and self-esteem. Yes, I can also make certain great machines and do the coding. And these my machines which I make, they can perform certain tasks. And it's like, wow, when students says wow, it's really achievement. So it has helped me to build my self-confidence and self-esteem. And I'm sure that when you learn robotics, you can also get this kind of confidence and self-esteem. Again, this is a life skill which will help you to crack interviews and progress in your careers. So I've got one question from where you learn robotics. Okay. Yes. So this is see, there are a lot of just I learned from YouTube, to be very honest. That is how I started learning robotics. I don't have any background or any degree in robotics. I am a BTech in biotechnology, and then I did my MBA. But I was always interested in making machines. So I learned initially from YouTube, and there are a lot of tutorials available on Google. I purchased Arduino from market and started doing projects on my own, very simple projects, like the first project which I made was of LEDs, how to blink LEDs in various patterns. I think most of us do this as a first project. Then I went on to making a pick and place device, and I made a model for the uh, a dynamo, how to generate electricity, and a lot of things I made. Initially, I learned from YouTube, and then yes, uh, when I when I realized that I need a structured approach, then I obviously went to my mentor. I in fact came to Indian School of Robotics, and my ma'am Priyanka ma'am was there, and she taught me in a structured way. So if you want to learn robotics, you can start from online YouTube and Google, and you can purchase parts from market. They are easily available. You can just go to Amazon or any other website, like RoboU is there, which supply parts. You just purchase them, get it at home. They are not very costly. You just need to invest 1,000, 1,500 rupees to get Arduino and little bit of other components. You start learning, and when you think that yes, you need to move to the next level, you can approach institutes like ISR, and there are many others also. And you just need to be sure what you actually want to learn and go as per that. So can you explain how we can send data from Arduino to ROS? Okay. Sagar, I'm sharing my email ID. Just write to me. I'll share the technical details, because this will involve little technicality. And anyone of you, if you have certain things, you can share. So my email ID is rohit.chadha, ROHITCHADHA @isrrobotics.com. I think that was all from my side. Any questions you have, anything about career in robotics, or anything, any wild question I can answer. I'll be happy to answer. Not related to robotics necessarily, anything. So Hitul is asking how to start career in robotics after BTech. See, you need to search for companies who are working in embedded system. Hitul, you just search for companies in embedded system. These are the companies. These are the core companies who are working on robotics right from scratch. So just search for these companies, apply, and get some skill, get some certification in robotics. So when I talk about robotics, you need to be certified in building the robots and also advanced coding language. Since you are doing BTech, uh, you must know Python, because that is the future, and you should know how to work with open source parts. So that is what I'll advise you, Hitul. Go for certain certified courses in programming language, mainly Python, and also for how to build robots using embedded systems. Yes, I'll share my email ID to all in chat. Sagar is asking, sir, as a mechanical engineer, can I pursue my career in any sector of robotics like electronics, programming, and designing? If I desire, see, I have come across many mechanical engineers who are excellent in robotics because as a mechanical engineer, you know how to build robots, you know how to design the robots, because you can actually build a robot from trash. This is what I've seen. You know, I have one person with me in my company who is a mechanical engineer, and he builds using trash. Like he will buy Coke cans, and he'll just go to that kabadi wala and pick up certain iron rods and things like that, and he will build from trash. So mechanical engineers are excellent in building. Only thing which they lack is programming, because I don't think you are exposed much to programming languages during your BTech. So again, I'll suggest learn programming languages. You should know at least 2 programming languages. Like embedded C is there, it is the basic, and Python. Python is the advanced. So why I always emphasize on Python? Because see, when we talk about robots need to have certain artificial intelligence in them. AI is all about robots doing work totally automatically. As a human, I am able to think and I can take my decisions. Similarly, I want my machines to be capable of thinking and take the right decisions on their own. So, and AI, if you want to do AI in robots, we need to learn Python. So that is why I always emphasize on Python. We should learn the future language today. Right. Anyone else? Sir, I'm working on home automation using IoT. I have a lot of problem. Can you help me through mail? Yes, sure. Send me a mail. Either I will help you or I'll connect you with one of my colleagues. What is the scope of robots in manufacturing? Yes, absolutely wonderful scope. One of the greatest scope of robots in manufacturing is welding. Whenever we make any machine like cars or trucks or bus in factories, welding is a very critical process. Welding is so that is a critical process where the bots are used for very accurate welding. So it has got wide scope in manufacturing. It was asking, sir, I have worked on Raspberry Pi, builded surveillance robot, so I'm looking to add more feature to it. Any suggestions? So your surveillance robot is like it's like a drone, or how it is? You can maybe give certain temperature sensors to your surveillance robot to sense humans, like thermal sensors. This is one of the idea which I have. Sagar is asking, I am in first year. How should I start and where should I start? Okay, Sagar, you are a mechanical engineer, so either you can buy the stuff and go to YouTube, or you can contact me also, or any other institute which can teach you embedded system. This is where you should start, Sagar. You should start from embedded system. So when I talk about embedded system, get a Arduino, get sensors, wires, LEDs, breadboards, servo motors, NEMA motors, and then you can start. So the course or the technology suitable for you would be Sagar would embedded system or Arduino. That is how you should start. You can contact me or you can just go to Google. Anywhere you can.
Sir, I am also first year student.
Yes.
कॉलेज मीन्स थोड़ा थोड़ा सब लैंग्वेज सिखाता है ना, तो आई एम लिटिल बिट ऑफ कंफ्यूजिंग मीन्स
ओके कौन सी लैंग्वेज आती है आपको?
आई स्टार्ट पाइथन
एंड इससे पहले और सी प्लस प्लस आता है फुली?
मीन्स स्टार्ट किया था, लेकिन सडनली उसके बाद नया लैंग्वेज चेंज कर दिया, तो फिर ऐसे कंफ्यूजन होता है.
ओके आप क्या करना चाहते हो?
Means my branch is I am first year AI/ML engineering. I started.
Okay.
So I have to career in this.
Okay. You are from which college?
I am from Pune ISBM College, School of Technology, Nande.
Okay, so you are doing BTech in AI. You are
हाँ.
saying, yeah? So you should go for Python. आप फिर C पे मत जाओ, आप Python करो in detail.
ठीक है।
जो भी उसकी लाइब्रेरीज हैं, ऑब्जेक्ट ओरिएंटेड लैंग्वेज हैं, पूरा पाइथन करो। एंड पाइथन करने के बाद यू गो फॉर मशीन लर्निंग एंड देन यू गो फॉर एआई. सो दिस इज
Yes, sir.
द प्रोग्रेशन लेवल. पाइथन, मशीन लर्निंग एंड देन एआई.
Thank you, sir.
Right. Hitul is asking, can I connect you for any doubts regarding Raspberry Pi UGB? Yes, yes, you can. All right. Anyone else? Welcome, Hitul. Welcome, Sagar. Thank you. My pleasure.
Excuse me, sir.
Yes, Sagar.
सर वी वर्क इन सर, अगर जैसे हम स्टिमुलेशन में काम करते हैं टिंकर कैट, अगर हमारे पास आर्डिनो ना हो तो हम उसमें काम करते हैं, हम उसमें क्रिएट करते हैं स्टिमुलेशन के थ्रू. तो सर अगर हमें रॉस से कनेक्ट करना है तो स्टिमुलेशन के थ्रू हम कनेक्ट कर सकते हैं रॉस से, या उसके लिए हमें फिजिकली आर्डिनो चाहिए होगा टिंकर कैट
आपको
के
किससे किससे कनेक्ट करना?
सर रॉस से, रॉस सीरियल के थ्रू अगर मुझे डेटा सेंड करना है तो मैं स्टिमुलेशन के थ्रू कर सकता हूँ टिंकर कैट के थ्रू, अगर डेटा रॉस को सेंड करना है.
रॉस से करना है ना, वो नहीं होगा, आपको फिजिकली चाहिए होगा, टिंकर कैट से नहीं होगा. दिस इज व्हाट माय अंडरस्टैंडिंग इज, बट आई थिंक आप मुझे मेल कर दो. आई सी, एक बार मैं चेक कर लेता हूँ, बट काइंड ऑफ नॉलेज आई हैव राइट नाउ अभी नहीं होगा.
Yes, sir.
राइट.
Thank you, sir.
Right. So you are asking, sir, what is stimulation? Okay. Virtual. Yes, stimulation is something virtual. Like you just go to tinkercad.com. आप वहाँ पे जाइए. Tinkercad.com पे क्या है कि वहाँ पे like I'm talking about Arduino and LEDs and sensors. All these are physical hardware. But इसका but every student can't have access to these hardware. So इसका एक alternative है, which is these objects are created. इनके 2D या 3D components are available on tinkercad.com. You can go there, create your account, and you can work with these 2D objects, 2D image of Arduino or 3D image of Arduino or 2D image of LEDs. You can make the connections virtually. And once you have made the connection, you can do the coding there itself on tinkercad.com. And once you have done the coding, you can execute the program. And if the program is right, then your Arduino or whatever the machine you have made will start working. If you have connected LEDs for blinking LEDs in some pattern, then LEDs will start blinking in on your laptop screen, and this process is known as stimulation. So आपको just वो दिखा रहा है screen पे कि though you don't have actual hardware, but how it will actually work when you have the hardware. So how the process is, why we have Tinkercad, because sometimes what happens, we make wrong connections with our hardware, then that hardware gets damaged. So one of the alternative is we can go to Tinkercad and make our design and test it, stimulate it and test it whether our connections are fine or not, and then we can replicate it on hardware. So one question was there from Nagma. It was about web development. Nagma was asking web development. Someone has asked me before also regarding MIT app. So I'll touch upon MIT app first. So just like we have a lot of applications in our phone, we have a lot of applications in our phone, like Facebook application is there, or calculator, or maybe a camera is also application. So how we can make these applications. But if you want to make your own application, but do you want to make a camera application which can actually detect a face when you're clicking the photo of someone, it can just write down the that this face belongs to Nagma. And this is the picture of Nagma. How we can make these advanced kind of applications, or any other applications, such as a torch, or maybe you want to make an application, of finding square root of some numbers, or for calculating or converting distance from centimeter to kilometer. So for this, we have got certain tools available. One of the tool is MIT App Inventor. It is being developed by Massachusetts Institute of Technology, where even if you don't know how to code, you can go there, create your account, and build various kind of apps. And once you made the app, you can again test it there on their website itself. And if it is working fine, you can then download on your phone. And Also, if your app is all right, like it conforms to all mandatory requirements and safety features, you can upload your app which you have built on Play Store, and then everyone around the world can download. So MIT App Inventor is only for Android phones. For iOS, there is no such free software or tool where you can go and build. Same comes to web development. Again, web development is a process where we can develop the websites. So we teach this course. Again, there are many programming languages uh, which are used for developing websites, starting from basic like HTML. But there Python is also used for very complex and animated website. So that is what about web development. Is there any platform for knowing about various sensors which will be suitable for Arduino Pi? So just go to Arduino website, Hitul. Just type Arduino on Google, go to Arduino's official website. There you will find all the information, including all the libraries, how to connect sensors. Same goes with Pi also. Go to Raspberry Pi official website. There you will find all the information, like what all sensors are available, what are other motors are available which can be connected to Arduino Pi, and how to make connections. You will get all self-learning tutorials. All right. Anyone else? Any questions? You are developing app through Android SDK to control Arduino. We have to use Wi-Fi or Bluetooth to connect Arduino and Android app. Okay. You have to use Bluetooth. Bluetooth से हो जाएगा.
सर ब्लूटूथ और वाईफाई यूज करने से हो जाएगा सर क्या?
वाईफाई के लिए आई एम नॉट श्योर, बट ब्लूटूथ से हो जाएगा. एक ऐप आता है इसका, देयर इज वन ऐप, आर्डिनो ऐप करके है. प्ले स्टोर में आप सर्च करोगे ना, एक ऐप मिल जाएगा, दैट यू डाउनलोड एंड उसके थ्रू कनेक्ट हो जाएगा.
सर ये MIT इन्वर्टर और मैटलैब में तो सर इसका खुद का कोडिंग होता है ना सर, तो सो वी हैव टू उसके लिए परमिशन मांगना पड़ता है समथिंग. सो सर वो एंड्रॉइड स्टूडियो से सर एक ऐप डेवलप करके वो जब ब्लूटूथ मॉड्यूल और वाईफाई मॉड्यूल आर्डिनो से कनेक्ट करके वी कैन एक्सेस ना सर, एक्सेस कर सकते हैं ना ऐसे भी?
हाँ कर सकते हैं. ब्लूटूथ से तो आई एम श्योर हो जाएगा. वाईफाई के लिए एक बार चेक करना होगा. एक बार आप ट्राई करो, कहीं इशू आता है वाईफाई में, देन राइट टू मी, आई विल गाइड यू.
थैंक यू सो मच सर.
Okay. Right. We can log off, or is there anyone else?
Sir, for future guidance, can we connect on LinkedIn?
Yeah, sure. I am available. You can search me, Rohit Chadha.
Thank you, sir.
Yes. So it was really great and very insightful to answer your questions. I learned a lot from your questions. It's जब भी students से बात करते हैं, it's always a knowledgeable session for me. I look at as gaining certain knowledge and new things from you. And एक आपका perspective पता चलता है, what you are thinking and what do you want to do, how the next generation is going forward. So thank you so much for your time and listening to me, and and thank you for the questions, especially there were certain wonderful questions, and if you're able to share your problems with me, जो एक दो जनों ने बोला है Wi-Fi and other things, then again it will be a pleasure, and I'll also learn in the process. Thank you so much. Let's
sir, last question, sir.
Yes.
Sir, is this a free session, sir, or we have to pay for this, sir?
Which session?
Sir, this one, sir, this webinar.
It's a free webinar.
So actually I have attended the maximum webinar. So at the end they will provide some kind of course, no, which is not productive.
No, nothing is there.
So this is from ISR, sir.
Yes, I am from Indian School of Robotics.
Thank you, sir. Thank you so much, sir. Such a informative session, sir.
Thank you. All the best.
Thank you so much, sir, for joining us today. It was a really informative session.
Thank you. All right. Thank you. Bye-bye. Thank you for the opportunity.
Thank you. Thank you, everyone, for joining.